Okay, in this stats video, we're going to do part 1 of a 4-part series on section 3.2. You're only going to have 2 videos to watch for today, 2 videos for next time. So we're going to do least squares regression. Describing relationships is our chapter 3. Here's our objectives for the overall 4 videos that we're going to do. You can read those yourself. We're going to be calculating, actually we're going to be concentrating on these 2 here for part 1 video, and then well, for the rest of them, calculate and interpret residuals and standard deviation. We're going to do that, but right now we're doing just part 1. Okay, so to get us started, we're going to talk about a regression line. So you should be familiar with a scatter plot. So a regression line is a line that describes how a response variable y changes as the explanatory variable x changes. And we often use a regression line to predict, here's your clue word, predict the value of y for a given value of x. So our regression line, we're going to be doing a lot of these when it comes down to scatter plots. Okay, it summarizes the relationship between 2 variables, but only in settings where one variable helps explain or predict the other. If you don't have a very good scatter plot, your regression line is going to look very, it's not going to be very helpful for you, but we'll get to that part when we get into the prediction portion of it. Okay, so it says this regression line predicts the price, there's your keyword again, the price from the miles driven. Okay, so there's your scatter plot. And there's a line that they drew that accurately, predicts the price of miles driven versus, the price versus the miles driven. Now, there's a couple of things in the regression line. It really is a linear function. So it will follow the format of y equals mx plus b, but we're going to get to that in a second in the next slide. It just predicts it, right? But it follows the format of y equals mx plus b, except we've kind of turned it around a little bit, okay? So interpreting a regression line is a model for the data. Model, there's your keyword again. So it's a prediction for the data, much like density curves. So it models the data that you want in the scatter plot, or that you have in the scatter plot. The equation of the regression line gives a compact mathematical description of what the model tells us about the relationship between the response and the explanatory variable. Okay, it's going to look a little different, as you can see. So, first of all, that's not a little typo above the y. It's actually supposed to be y with a little bar with a little hat above it. So we say y hat is equal to the a plus the bx. And please notice that the bx is actually going last and the a is going first. So b is going to be your slope of your line, and a is going to be your y-intercept. So it's not, usually you're like the mx is this one, and then there's your b. So in your calculator, when we actually do this, and I'll show you how to do it in class, you have a and then the bx. So actually, I might just show you this right now. Here's the data that we had for the one that we did in class. Which was just some numbers that we pulled from one of the examples, okay? So what I usually do, because it really kind of doesn't matter, I say, okay, so I'm going to go to, give me just a second really quick. There's 2 different ways to do this, okay? If you go to, I was in stat, right? And then I go over to calc, and there's 2 of them. So there's one for number 4, and there's one for number 8. If you press the number 8 one, you're going to get the same, you're not going to get the same values for A and B, but your stuff's going to be a little, it's just going to be backwards. So your A value for this one is going to end up being the B value for this one, and vice versa. Your A value for number 8 is going to be the same as your B value for number 4. So you just have to decide which one you're comfortable with. If you could get away with just doing 4, which should be okay. Let's see what I want. I'm going to calculate. So I have my A value, or my B value in this case, so my linear regression. My B value is 16.26. So if I go to the other one and I calculate the linear regression for number 8, then my A value is now 16.26. So you just have to make sure you understand which one's which. You can decide and you can choose on your own on this one. The problem is the interpreting. So we're going to get to that in the next slide. Okay, so that was stat, right? Calculate 4 or 8. Well, either of the two, whichever you're comfortable with. All right. Interpreting. Okay, slope and the y-intercept. So for this one, P hat, or the price, right, because the y-intercept is actually talking about the prices in this case, is equal to, so your equation, I'm just going to do this really quickly because I don't know why they do this, is 38257 minus 0.1629 times x. Okay, so you have P hat, or the price, the predicted price. That's what the little hat means. Your predicted price of your linear regression, right? This line that goes through your data points is going to be equal to 38257 minus 0.1629x, or x being the miles driven. Your predicted price, right? Problem is identify the slope and the y-intercept of the regression line. Should be okay to do, and interpret each value in context. Okay, so here we go. The slope should be okay. I'm going to zoom out real quick so you can see a little bit better. All right, we have, let's see, the slope B is B equal to 0 is equal to negative 0.1629, right? Which tells us that, what do we have? The price. Let's see, what can you say about the price? The price is, well, it's changing y over changing x. Okay. The price of a used, what do we have? Ford. I think this is the car. Yeah. Ford F-150. Sorry, you didn't know that part. That was in the, that's actually one of the examples in the book. This whole thing is about a Ford F-150 car, and it has a bunch of miles driven versus how much they were sold for. I'm pretty sure, yeah. The price of a used Ford F-150, okay, is predicted. There's that word again. Predicted, okay, to go down. To go down negative 0.1629. The price, well, predicted to go down 0.2 dollars, right? Per, so dollars per 1 mile driven. Or for each additional mile. So for every 1 mile that you drive the car, you're basically predicting that you're going to lose 0.16 or what, 16 cents to the dollar for every mile that you actually drive the car, right? And then the second part, that was for the slope, B. The y-intercept, or basically A, equal to 38257 is the predicted cost of a Ford F-150 that has 0 miles, or that has been driven 0 miles. That's a little bit better. Or that has 0 miles on it. Or that has been driven for 0 miles. So presumably, it's just coming off the, it's not even actually coming off the lot. Because even on the lot, it actually has a few miles on it, like 2 or 3 miles or something like that. So literally is just coming out of assembly line. So the predicted, right, there's your keyword, the predicted cost of Ford F-150 that has been driven for 0 miles is $38,256. Okay. All right. So that's interpreting slope and interpreting the y-intercept. All right. We're going to get more practice with that when we get to class. But the thing about interpretations or predictions, more than anything, is that we can use it to predict our line. Not predict our line. We're going to use our line to make a lot of prediction about your scatter plots. More importantly, we use it to find the prediction value of a specific explanatory if we know the actual response, or vice versa, for that matter. Okay, so use the regression line to predict for a Ford F-150, okay, with 10,000 miles. So you're basically predicting your price. Well, it's pretty much easy to do because you just plug the values in. So if you know that this was the miles that was driven, right, you're predicting the price, then you can just substitute. If X is your miles driven, then you should get a P hat of 38257 minus 0.1629 multiplied by 10,000. So if somebody is driving this car for 100,000, not what did I say 10,000? I meant 100,000. Then you get 38257 minus whatever that is. I'm pretty sure I just have to move the decimal point over. Watch it. 0.061 629. Why are my numbers so small? Multiply by 10,000. What? What is this thing doing? Okay, there we go. Yeah, I just moved the decimal points over. Okay, how many places am I going? 1, 2, 3, 4, 5. So 16290. Yep. Do I have enough zeros? Yep. Okay, we're good. So 38,257 minus this amount should give me about 21,967. So the predicted price is going to be 21,967. So we're going to write that up. The predicted price for an Ford F-150 that has been driven for 100,000 miles is $21,967. Okay. Okay, and then you can do the same thing backwards. If I give you the price for something, you can plug it into, or if I give you the Y value of something, you can plug it into there and then solve for X. The same thing goes backwards. Okay. All right, and then the last thing, extrapolation, which is very silly to talk about, but unfortunately it's needed. So you can use a regression line to predict the response of Y hat for a specific value of the explanatory variable X. The accuracy of the prediction depends on how much data scatters about the line, which makes sense. While we substitute any value of X into the equation, you can still substitute values of Y into the equation if you need to. Extrapolation is the use of a regression line for prediction far outside the interval values of the explanatory variable X used to obtain. Such predictions are often not accurate, and I'll show you exactly what that means using the previous slide. Don't make predictions using values of X that are much larger or much smaller than those that actually appear in your data. So here's what we mean. Now, if we say, let's see, you don't know any better. So for all that you know right now, your data curve is going to get cut off your data gets cut off right here. But technically, the line is going to keep on going. It can keep on going up in this direction, and it keep on going in that direction. So here's what we mean. What if it hadn't asked you to find 100,000 miles driven? What if it had asked you to actually find 200,000 miles driven? right? So we can calculate that, and I'm going to because I want to show you what happens. So let's pretend, okay, let's predict, okay, what would happen at 200,000 miles. Okay, we want to know, is that, how much would you expect the car to cost? Okay, well, there we go. So P hat is, what was it, 38257 minus 0.1629 times 200,000 miles. Okay, so I'm just going to plug this straight into the calculator because I can just do it really quickly. So 38257 minus 0.1629 multiplied by 200,000. 123, okay, and I get a value of, oh, that still works out okay. Okay, so I get a value of 38, is that right? 5677. Okay, so I get a P hat value of 5677. Okay, so that works out. So far, I'm still, I'm still going to make some money on this car. It's getting really close. I wish they hadn't scaled it that way, but it's getting really close to, 5,000. Okay. But what if I've driven this car for like 500,000 miles? And I'm just going to really exaggerate here, which is probably never going to happen. But, you never know. Okay. So my P hat, and I get 38257 minus 1 or 0.1629 multiplied by 500 or 500,000 miles, and let's see, nope. Good Lord, clear. What is the matter with you? Okay, 38257 minus 0.1629 multiplied by 500,000. Okay, I get a predicted price of negative 43,193. Okay, and this is what I was trying to get for. 200,000 miles apparently was still a reasonable amount of mileage. So we know 500,000 miles is never going to happen, but there might be cars out there. And the only question is, does this price actually make sense when you have a predicted price of negative $443,000 and 193? So what does that mean? Is someone paying you to drive it now? You know what I mean? So that is when it doesn't make any sense. This is a bad this is a bad solution. The prediction does not make sense. Okay? The prediction does not make sense in the context of the problem. Sorry. The prediction does not make sense in the context of the situation. Okay? You're never going to get negative 43, $1,000, 193. It just won't. It just doesn't make sense. So that means you extrapolated too much. You used your regression line a little too much. Okay. All right. So that's it for this video. And then the next one's probably going to be a little bit shorter too. So we'll see you later.